Hello everyone, welcome to Finite Element Analysis Laboratory by Youni-Learning, episode 14. This is our final episode related to the ANSYS Workbench software for static structural module. We will perform the stress intensification in this analysis. Kindly subscribe the channel for more recent updates. Our objective is to determine how to conduct the stress intensification on a plate with a hole, and you can perform this same experiment for a plate without hole to compare the results. Our goal is to model the plate in an axis symmetric element in a 2D space and compare the results of actual and finite element method results. As you can see, this is our rectangular plate on the right hand side having the properties given as follows. The plate is made up of A514 grade steel with modulus of elasticity 29 e raised to the power 6 psi and Poisson's ratio 0.3. The thickness of the plate is 0.2 inches, the diameter of the hole is 0.5 inches, the length of the plate is 10 inches and the width of the plate is 5 inches as shown in the figure. We will model this geometry in an axis symmetry, means we will only model only 1/4 of the portion, which is this one. The rest of the portion we will define the axis symmetric boundary conditions for this. We can get a reasonable estimate of the hole and the without hole stresses and strains by using these formulas. For these formulas, we have considered that the plate is without hole, and these are the properties that we have determined accordingly through the analytical results. And we have constructed this table. This comparison table shows you the theoretical method results, and on the right hand side you can see the finite element method results. You can compare these results by performing the analysis and calculate the error. And we will define a graph within ANSYS Workbench software in which we will use the length of the plate and along x-axis, and on y-axis we will plot the normal stress to determine the distribution, how the stress is increased rapidly along a stress intensified section, which is the hole. This and now we will towards the ANSYS software for performing this analysis. As you can see, this is my ANSYS Workbench window. Kindly go into the analysis system and select static structural module by double clicking on it. And this is our final episode, so I will write final episode. Press enter. Now go into the engineering data to define the properties of the material. As you can see, all of the properties are given in the SI units. We will change the units from here. Go in units and choose the US customary units. Units US. It is not updating, so we will remain as it is because these are the properties that of the structural steel. Now go into the geometry and change the analysis type from 3D to 2D and perform this step at the start of the analysis. If you perform this step later in the analysis, it will not incorporate correctly in your analysis system. Now right click on the geometry, go to the new design model. We will define the geometry in this section. The ANSYS design modeler, which is the ANSYS CAD software, we will model the CAD geometry here. You can model this geometry in any software and can import it in ANSYS Workbench software. Now click on the XY plane and click here on the look at command. It will convert the 3D axis into a 2D axis and go into the sketching window. From here, kindly change the units first into inches because all of the dimensions that are given to us are in inches. Now select a rectangle and select the origin and draw a rectangle on the right hand side like this. After defining this rectangle, kindly go into the dimensions tab and place two dimension holders here like this. One is horizontal and other one is vertical. Enter the dimensions of this according to these parameters, which is states that the value from here to here is 5 inches and from this point and above is 2.5 inches. So we will enter the vertical to be 2.5 inches and here it will be 5 inches like this. Now go into the draw tab again and select circle and draw a circle here at the origin of any dimension and go into the dimensions and enter and place a dimension holder here. The value of the radius of the hole is given to be 0.5 inches, so it will become 0.25 inches. So we enter the dimension here to be 0.25 inches, but it is a diameter, so it will become 0.5 inches like this. Now go to select auto fit and go into the modify tab and select trim to trim this extra portion of the circle, and we will also remove this extended part of the rectangle like this. Now our plate with a hole, which is 1/4 of the portion, has been completely modeled. Now go into the concept and select surface from sketches and go into the XY plane and select this sketch one, which is our created sketch, and click apply. After applying, click the generate button and it will model your ANSYS 1/4 of the rectangular plate with a hole. Our geometry has been completed up to this point. Kindly close the design modeler window and go into the ANSYS Workbench window and double click on the model tab like this. It will start ANSYS mechanical module in which we will further input the parameters that are required for the purpose of conducting this analysis. As you can see, it is extracting the geometry that we have previously created in the previous step. Now go into the ANSYS model like this and right click on it and go insert and select symmetry and change and go into symmetry again, right click, insert symmetry region and select this edge only and click apply and change the axis. Let the axis remain be x-axis. Similarly, again insert symmetry region and select the symmetry along this edge and click apply and change and select its perpendicular axis, which is y axis. After defining this, generate the mesh. It will create the by default mesh of the ANSYS. As you can see, the size of the mesh is quite large, so we will change this size by changing first the units first, and we will select the inches units, and it is 0.4, we will select 0.1 inches and generate the mesh again. We have reduced the mesh size by 1/5 like this. Now we want to reduce the mesh size here at this particular region. For this purpose, kindly right click, go to the insert, left sizing and select this face and click apply and let the size be 0.1 inches. Similarly, go into the mesh again, insert and select refinement, because we want to refine the mesh along this particular edge, which is the hole, and click apply. It is not selected. I will again select this edge and click apply. Now the edge it is not selecting. I will change the option from here, the 3 selection cubes, and select the edge selection cube from here. And now I will select this edge again and click apply. Now the edge has been successfully selected. We will change the refinement from 1 to 2, and now we will again generate the mesh. As you can see, the mesh at this particular region has been further refined. Now we will assign the boundary conditions, in which we just have to specify the pressure, which is 1 psi. I will enter. I will select the geometry first and enter the magnitude to be -1 p6, which is 1 psi. Now go into the solution, insert, deformation, total, solution, insert, deformation, directional, and again I will insert directional and will change its direction from x to y axis like this, and will now right click on it and select it, rename based on definition, and rename based on definition again, which shows that x and y axis are created. The last thing we will do is we will insert a normal stress by going to the stress and selecting normal. Now our results has been successfully added. The last thing we want to create is a graph which shows from this origin to the right hand side of the plate, and the y-axis will show its deformation. For this purpose, kindly move above and right click on the model tab, go to the insert and select construction and path. If this option is not showing, only select the construction geometry first. It will create this tab and right click on it, go to insert, it will select the path. Now this path is selected. We will only enter the dimension. The starting point will be at the origin and the ending point will be along x-axis, which is 5 inches, like this. As you can see, the path from 1 to 2 has been successfully created. Now we will again insert stress normal and will change the method from here, geometry selection to path selection, and select the path that we have recently created. Now solve the model it will calculate all of these results here. Like this. Now first we will use the total deformation. As you can see, this total deformation shows that on the right hand side, due to the applied pressure, the deformation is larger, which is 0.176 inches. Similarly, along X, it is 0.1765, which is equal to the total deformation, and along Y, it is due to the Poisson's ratio effect. And now the normal stress is showing that this region has the highest normal stress. We will plot this on the ANSYS Workbench software, and we can have this plot here. From 0 to this point, the hole is placed, so there is no stress being applied because it is a hole. After this, the stress is continuously increasing at a rapid rate, slope is high, and after a certain length, let's say 2.5 inches, the value of the stress becomes equal to 1 e raised to the power 6, which is the applied pressure. You can comment this in your report. Okay, now our experiment has been successfully completed. Kindly close this window from here and save the project first by going to the file, save as, and save the project here under episode 14 stress concentration and press enter. After saving the project, go into the file again and save it as an archive file and press save button. Select all these boxes and click archive. Our project has been successfully created. Thank you very much for your patience. Kindly comment below if you have any questions. I will try to answer them as soon as possible, and also subscribe the channel. This video has been completed. We will move towards another analysis system later part. Thank you very much. Goodbye.